Hello, Mr. Stone here, and we are going to look at how to model a periodic phenomena with the sine function. So for starters, we're going to look at the average monthly high temperature in the wonderful city of Chicago over the course of a year and figure out how we can model that using our sine function. We're going to start by just looking at our basic model of a sine function. Remember your A right here, that is for amplitude. Your sine is, well, that's right there. B is your horizontal stretch or compression, just as I'm sure you've seen before with stretching and compressing functions. X is going to be your variable. It could be t, which might be apropos in this case because we're talking about time, but it's your variable. C is your horizontal shift or translation. And then D is also going to be, that could be our vertical shift, or we're really thinking about this as our principal axis. This is what the sine wave is going to kind of oscillate around, go back and forth over. All right, so that's what we've got. That's where we begin. Let's look at the data. And here I am. I've got, I can see I've got a wave that's kind of going up and coming down. In particular to note is I've got a high in July of 84 degrees. I've got a low in January of 32 degrees. So working with those two things, working with the high of 84 and low of 32, I've got my maximum, my minimum there. Your amplitude is going to equal 84 minus 32 divided by 2. Okay, and 84 minus 32, that gives us 52 over 2, which is just 26. So we go back up to our equation, and then what do you know? We've already got our A of 26. Sine is coming up next. We could go to B right now. I'm going to hold off on that one a little bit because I want to get to D. Since we're already talking about the maximum and the minimum, your principal axis, your D, is going to equal your maximum plus your minimum divided by 2. In this case, we get 116 over 2, which is equal to 58. So we've already got A and D just like that. All right, now let's look at B. B is talking about the length of the period. And check it out, I've got a whole year of 12 months. So I know that my period is going to equal 12 months, or 12 units, 12 months in this case. So I know that that's going to be 12. I also know that my period is going to equal 2 pi over b. And if 12 equals 2 pi over b, then we know that 12b is going to equal 2 pi, and therefore we know that b is equal to 2 pi over 12, which is just pi over 6. There we go. Now, multiply this by our variable x. I'll call this t. Okay, that's my t, simply because we're dealing with time. It doesn't have to be x, right? If we're talking time, it can be time. I just give the warning because my t's can be quite terrible. But minus what? Minus our c. So let's look for a moment here, just kind of step aside to look at what an average kind of sine wave looks like, okay? It starts low, goes high, comes back, there's your full period. We go all the way up here, up to your amplitude. We go all the way down here to your negative amplitude, basically. We have a few x-intercepts. And we start at the origin. Okay, if this is just plain old vanilla y equals sine x. What we're going to want to do is to shift the starting point, which really means shifting this whole thing really to the right until the point where where we see that the wave kind of start. So let's go back over here, and it's taking a second for me to write. Okay, there we go. So notice how right here I do have the sine wave going, but I'm starting really low. I'm starting near what pretty much is my minimum, right? We said that January was the lowest that you could get. And if we look back at our graph, we don't start at the minimum. We start at the principal axis. So we really want to start, we already talked about having a principal axis of, if we go back up, of 58. So we really want to start somewhere around there, ideally. This one is very pretty in that it works out quite nicely in a couple of different ways. So I can look here and I see this, 58 degrees, that's right below this 60-degree line. And hey, how about that? Right around April, and if we're looking at units, there's 1, 2, 3, 4, right around 4, it happens to intersect that 50-degree principal axis. So that would be a great place to start. Shift over 4 units to the right by saying we're doing a horizontal shift. This would be t minus 4. That's it. But it worked very nicely this time. It was very pretty. What if it's not always so pretty? So let's look at another way that we could figure out exactly where to start. And again, what we did by doing that, that 4 is we really, where did it all go? Oh no. I can't write on it. Darn it. Okay. Let me see if I can reboot that. When we slid that to the right, we really just, oh, now it's writing. Okay. And I've got the cold on here too, but just disregard. What we really did was we slid the start from there, from where our 0 really was, 4 units to the right to April. Okay, that's why we did the shift. But let's look at one other thing that we could do in order to get our starting point and what we need to shift to. If you think of it like this, think of it like here's our maximum, okay, and this would also continue on. Would go. You've got another maximum here. I'm sorry, that's like totally, whoa, that's a terrible graph, but bear with me. You've got a minimum right there. We saw before that if we made some slices right there and right there, I know it doesn't look like it on this graph because my graphs are terrible, but you've got pretty much the same distance here. This distance is the same as this distance. I know it doesn't look like it, but bear with me. So really you're finding the midpoint between these two and using that as your start. We could do that if we look back at over here. My max we said was over here at 7, and my minimum we said was at 1. And if we take 7 plus 1 divided by 2 to get an average, to get the midpoint there, that gives us 4, and hey, that's what we already said would be perfect. So that's another way to get it. Look at your maximum. Let me change colors. Look at your maximum. That's a 7. That's a 7. Look at your minimum. Add them up, average them, and you should have a point that's in the middle along the x. And because it's your maximum and your minimum, if it's following a sine, roughly a sine wave, it should also be in the middle vertically as well, which makes it a great place to start because, again, we go from that point, then we go up, we go down, and then we're going to start coming up again like a sine wave. Okay? Review this, bring in your questions, and just have a great day.